Hey everybody, it's Brennan. I wanted to send a video out to you guys this weekend before we start off the weekend. It's Friday, um, and it seems like there's a lot going on in terms of information sharing, and I just wanted to highlight a couple of points that I've seen this week since I've had a lot of time to read through research and try to extrapolate what the heck's going on here. I know that there's another polarizing issue on our hands in terms of politics about what we should do in the community. Is it safe yet to open? Is it too soon? Will there be a relapse of COVID cases? Can the economy handle it? Is there a bigger um, mental health toll? And I've even heard of a few cases of suicide, and that's people that I know, not just like someone you see on the news. So this is definitely a real thing. It's a real problem, which is kind of what this group's all about, solving real problems. So I wanted to share some information that I think is important, so that you guys can all kind of extrapolate for yourself what you think is relevant and what the best thing to do is. This is all about making informed decisions. So I'm here to inform to the best of my ability. So just real briefly, there's a few things I've seen this week. Um, Stanford Medicine started developing a test for seroprevalence. What seroprevalence means is they test your serum for how prevalent antibodies of COVID are if you have the antibodies for COVID. Now, it's important to understand that just because you have antibodies does not mean that you are immune to the virus. It just means that you've been exposed to the virus, and so you're probably in the process of developing an immunity. So one thing that's been done is we've been using what's called PCR, or polymerase chain reaction test, to figure out if people are positive for COVID. It's been shown through the research that that's actually not a very reliable test. The person who created that test, it was never intended to be used for that purpose. That's not really what I'm getting into today. If you'd like to research that on your own, by all means, and if you need help from me to find the answers to those questions, please reach out. But this is not what PCR was originally developed to be used for. PCR, basically what they do is, we did this in biology undergrad classes, where you have like this gelatin material and you take a DNA sample in a syringe, and you basically inject it into these little holes in a gel solution. And if you do it right, what's going to happen over time is these DNA strands will replicate across the little gel, and you'll be able to isolate the DNA, which is really cool. That's what it was meant for. But in this case, we're using it to determine if people are COVID positive. So Stanford Medicine, some really smart people, way smarter than me, said, you know what, we should probably be testing for antibodies. And so they developed this test to be able to see if they can find these antibodies. And so these guys came out and published this study about 8 days ago. And this is what I've been sharing with my patients to try to bring the fear levels down, to try to keep people calm, because we don't need people going off the cliff. What they're finding is that the prevalence of COVID is actually much, much higher than what some of the early statistical models were showing us. Now, here's some things to consider. This study was done in Santa Clara County, California. This is a region of the country that was supposedly hit really hard by COVID, so there's a good area to look at. They looked at about 3,300 people, which is a sizable population sample, but it definitely doesn't compare to the actual population that we have in the United States. But we definitely shouldn't look over the results of this. We shouldn't look past the results of this study. They're definitely significant. What they found is that the prevalence of antibodies in the community is about 50 to 85 times higher than what we're being told in the media. So the reason this is important is because when you go to calculate death toll is what's going to make people freak out. It's what's going to, if we can show statistical projections of what the death toll of a disease or something would be, that's what's going to start to have an impact on policy. the government policies, things that we do. So shutting down. So the death toll, if it's high, obviously we freak out. So the way that we calculate this is we look at people who have died from COVID specifically over the number of total confirmed cases. And so if you know how many people have it and how many people have died, there's your death toll, there's your percentage. And so that's something that we would use to make decisions. Some guys at Imperial College, a university in Britain, looked at this stuff, and this guy named Neil Ferguson, he's an epidemiologist and infectious disease specialist, I believe, looked at these viruses, and he uses mathematical models to project what type of impact this is going to have on a community or on a population. Historically, this guy has been pretty wrong just about every time he's gone to try to predict something. God bless his soul. He really seems to try. He's a super smart dude, but just can't seem to get the answers right. But what's the problem is that even though he's been wrong many, many times about how widespread these problems will be, we continue to listen to him and base policy off of it. So his original statistical models of how COVID would spread are not, have not shown to be true. They were drastically overprojected. So that's one reason I think people started to freak out in the beginning. Another problem is people died from COVID. In order to calculate that numerator, you have to look at how many people got coronavirus and died because of coronavirus. And what we're seeing is that these numbers are being overreported by doctors. And I'm not sure why that is, but we know for a fact that there's people in hospitals who are dying because of different reasons: diabetic complications, pneumonia, upper respiratory problems, cancer, accidents, slips and falls, trauma, but they're being tested for COVID. And if they just so happen to have COVID, they're saying that the reason for death is COVID. And that's problematic, because it doesn't mean that they necessarily died because of COVID. They just so happen to have it at the same time. In fact, the governor of Connecticut is being sued by a citizen of the state because he claimed that a 9-year-old boy died from coronavirus, and the mother said, no, that's not true. He had an accident at home. He fell, and it was a traumatic injury, and unfortunately he passed, but he did not die from COVID. And so there's a problem in and of itself. We know that the reporting is not 100% correct. So if that numerator is higher, that's going to make the death toll higher. Now, the other problem is total confirmed cases, the denominator. Okay, so if the denominator is lower, that's going to also make the percentage, the death toll, appear higher. And so this is where this Stanford study comes in, and it's really important because Stanford is saying that we are not reporting how many people what the actual spread of this disease is in our country. They're saying that it's 50 to 85 times higher than what we're seeing. And so you could imagine if that denominator is lower, that's also going to bump up the death toll, which is not good, because that's what makes people freak out. So in this study, they accounted for the fact that the total confirmed cases, the denominator in this equation, has been underreported due to the lack of testing, which you guys are all aware of. So they accounted for that. What they did not account for in this study is that the people who have died from COVID number is being overreported. So that's another conversation that we need to have. But just accounting for the problem with the denominator, they showed that the death toll for COVID-19 is actually similar to what a seasonal flu would be. And so if that is the case, now we don't know if that's a fact, because again, this was a study done on 3,300 people, and there's a lot more testing that needs to be done. And there's other scientists who are going to come out in peer review and say, well, you should have looked at these things. So it's not a fact yet, but let's just say hypothetically that the death toll is very similar to what a seasonal flu would be. That would drastically change policy and how we're behaving as a society. People wouldn't be walking around with masks, which, by the way, I personally believe that the masks are important to a certain extent. You know, I get that respiratory is how we spread this disease, touching things, and it's communicable. However, there's been studies that have shown that cloth masks allow 97% of particles to come through, and even the medical grade masks are allowing about 48% of the particles to come through. So it's really not protecting people, and it propagates fear. So that's unfortunate, but you know, obviously people with comorbidities are the ones who are really suffering and dying from this thing. So if you have someone at home, or if it's you yourself, yes, go those extra measures and do as much as you can to protect yourself and your loved ones. So there's a lot of different things at play here. The other thing I want to bring to y'all's attention is a very basic chart of how immunity works. This is important. So where there's two types of immunity. There's innate immunity and adaptive immunity. Innate immunity is what you're born with, innate being inborn, meaning inborn. And so basically innate immunity is very immature, and it just recognizes anything foreign, and it creates inflammation and attacks it. And this is not always the best case, because this is how we develop autoimmune conditions if it's too active. What we really need is what's called adaptive immunity, and this is why people vaccinate. So the idea behind vaccination is that if we inject this artificial version of this this disease into you, it will stimulate your immune system into creating antibodies and learning how to recognize this disease, doing its homework, so to speak, so that when you are exposed to that pathogen out in you know, the world, you will have an appropriate response. The problem is artificial, well, I find this very fascinating. Artificial man-made versions of this stuff is never as strong as what the body can create itself. We preach this in chiropractic all the time. So what we really want to do is get people to have a natural adaptive immunity to certain diseases and pathogens. So this is going to be stuff, you know, you get through the placenta, through the breast milk, through being exposed naturally to these viruses out in public. So, you know, when we were kids, we would all, you know, our parents would send us across the street to play with the kid who had chickenpox, because they knew if we were exposed to that varicella virus that we would develop our own immunity. And guess what? That's lifelong immunity. It never goes away. It doesn't need a booster shot. If you continually if you are continually exposed to this out in the community, that's your booster, so to speak. So call me a hippie, but I really believe in that stuff, and science has shown that it's actually stronger that way. So there's another conversation we need to have. Should we then be lifting stay-at-home orders so that people can get exposed to this virus that hypothetically could have the same death toll as a seasonal flu, which we don't freak out over? And viruses spread. I mean, you know, people get viruses. We have a human virome inside of us. There's so many microbes that we interact with on a daily basis, and it actually makes up our cell material, and it allows us to function properly. So it's almost like, should we look at this thing as an enemy, or should we look at it as a potential adaptive measure, something that we can overcome to become stronger as a species? And ultimately, you know, we don't have the answers for this yet, but I think that the debate is going to center around a cohort of folks who believe that the body is not strong enough to do it on its own. And then there's these other people like me that truly believe that the body has evolved over, you know, thousands of years to be able to fight these things off. So this is just some food for thought. I wanted to share this stuff with you guys. I didn't intend for it to be this long. I just wanted to throw a couple ideas out. There's a whole lot of research that's out there that you guys can be doing on your own. And if I can help to stimulate those thought processes with you, I would love to be that. Please feel free to text me, or, you know, shoot me an email or something to continue this conversation. I hope we get to it in the group. But these are just my very tip of the iceberg, surface level thoughts. I hope I didn't ruffle any feathers too much. These are just things that I think, as a health professional, as a doctor, that we should be talking about and truly considering. And I don't believe that fear is the way. And I feel like just about everybody in this group would agree with that. Love all you guys. Appreciate y'all. Have a great weekend. And I will see y'all hopefully in person, not over video, very soon. Bye-bye.